I started.
Okay, I'm checking. Yeah, it's live now.
Okay, fine.
Okay, fine.
Hello my beautiful students, so good morning. I'm so sorry because of some technical glitch the session started a little late. I'm really sorry that I've seen few students there just wishing me good morning and all, so thank you for holding your patience. So without further delay we can start our sessions. So yes my dear, by solving this, can we score 65 plus? Yes, definitely. By solving this, definitely you can score 65 plus. It's my assurance to you. I can see people out there. Please just make sure that I'm visible or audible properly. Just let me know in the comment section. So here what we are going to do today, let me tell you just a little brief about it. We will actually do a little bit MCQ and an overview of the chapter I will give to you, and most importantly we will solve some numerical problem for the physical chemistry. Okay, this is my main target. Okay, so yes, let's proceed. Okay, I can see Sumit Kumar. Tomorrow is my first PUC Chemistry final exam. Need your blessing. Definitely my blessing is always with you my dear. Please make sure you are going through the 2-3 marker questions. Expected that the questions will come from there. Okay. So yes, let's proceed. So first definitely we will start with the first chapter solution. So I will at first start with some MCQ, and then slowly a little bit numerical problem I have planned for you, and then a little bit most important 2-3 marker that comes within 50 top question through all the chapters that I will cover. Okay, so this is my plan for today's class. Let's proceed. Later on definitely individually it will come physical chemistry, organic chemistry and inorganic chemistry. So yes, we will finish it up like that only. Okay, so first let's begin with the solution chapter. So here comes the first question. So few most important MCQ I have taken. Those are very much important because those were those are taken from your question bank, from from your model paper as well. So make sure that you are giving proper response here in the comment box as well. So yes, let's get started with the first one. So here you can see 10 ml of a liquid A and 20 ml of a liquid B are mixed at 25 degrees Celsius. The volume of the solution was measured to be 30.1 ml. So what's basically happening here? So 20 ml and 30 ml you are mixing. So once you will mix these two, you should get 30 ml, right? But here you are getting 30.1, means delta V mix, is greater than 0, right? It is 0.1 more, right? So in case delta V mix is positive, then definitely it will show positive deviation of Raoult's law. And positive deviation also indicate delta H mix also greater than 0. So if you just look at the option, your correct answer is going to be option C. Okay, I can see Amaya 050 is giving correct answer. Very good my dear. Let's proceed. Next question. A student took 2 glasses of pure water from water filter. He cools glass A in a fridge and warms the other glass B on a stove. On comparing the solubility of oxygen in H2O in glass A and glass B, he stated that the glass A contains first more oxygen than glass B, less oxygen than glass B, and the same amount of oxygen as in glass B, 0 concentration of oxygen. So what is basically happening? If you increase the temperature, solubility decreases. They are inversely proportional to each other. So whenever you are cooling the solution down, whenever you are cooling down the solution, cooling down the water, then there will be more dissolved oxygen, right? More solubility of oxygen will be more. So definitely as you are cooling down the solution, the glass A will be having more oxygen than that of glass B. Option A is going to be the correct one. Okay, Rakshita, very good. Let's proceed for the next question. Here you can see statement based question. Statement 1, if on mixing the two liquids the solution becomes hot, it implies that it shows negative deviation from Raoult's law. What do you think about it? So yes, if two liquids you are mixing and it becomes hot, right, it means del H value, del H mix is definitely going to be negative because it's an exothermic reaction, right? Because it's an exothermic reaction. So delta H mix value is negative. It means it is negative deviation, right? It means it is negative deviation. So yes, first statement is true. Next you can see solution which shows negative deviations are accompanied by decrease in volume. So that is also 2. Whenever you are showing it is showing the negative deviation of Raoult's law, delta V mix is also negative, right? So this question, both of them are true. Okay, so yeah, let's proceed. The mixture shows positive deviation of Raoult's law. Yes, please tell me. I'm expecting this answer from you people. We have N-hexane and N-heptane. N-hexane and N-heptane, they are similar type of compound. So it is expected that they will show similar type of interaction, right? So it is ideal solution. Next, bromoethane and chloroethane, they are also same type of thing. So again ideal solution. Ethanol and acetone, so whenever it comes to the matter of ethanol and acetone, AB interaction is weaker than that of AA and BB interaction, right? So that's gonna be the correct answer. It will show the positive deviation. Okay, Amaya, very good. Let's proceed further. Here you can see a binary solution has two components A and B. The mole fraction of the component A is 0.5. Then the number of moles of component A and B in the solution. So if the mole fraction of A is 0.5, B must be 0.5. So in order to, if you are having, if you are having both of them of same number of mole fraction, then number of moles are expected to be similar. So this is also going to be C. Okay. Okay, so I can see Basavaraj. Okay, Basavaraj, you give so difficult names, I can't even pronounce. Okay, if we read this, is this enough? Yes, definitely that's going to be enough because that will contain 50 top important questions. Okay, I guess some cases more than 50 I have kept here. So yes, those whatever I have kept, it's definitely it's going to cover the entire thing. It's going to be important, and yes, you can face those things. And after this, definitely, as I told you, I'm going to do individual physical, inorganic, organic. So make sure that you are watching the entire session to understand what type of question you can face. Yes, it's important. Yes, 60 marks, not 60 marks, 70 marks you expect. Okay, let's proceed. I guess you understood this. Let's proceed further. The mass percentage, weight by weight of glucose in water, 10%. What does it mean? So 10%, 10% means in 100 gram of solution, I am having 10 gram of solute, 10 gram of glucose. So if I am having 10 gram of glucose, 10 gram of solute, what is the amount of solvent? Solvent is water here. So 100 minus 10, that is 90 gram. So 10 gram glucose dissolved in 90 gram water. Okay. Okay, Chitra, the answer is not B, my dear, because you can see weight by weight they are asking, not weight by volume. If they would ask the weight by volume, then we could think about it. Okay, I guess it's clear. Let's proceed. Okay, so one more thing that I wanted to tell my dear students, so if you are really preparing hard for your KCET examination as well, so Diksha Karnataka has launched our KC30 batch. So in this batch we have 30 days live online session that will be provided by the expert faculties. Previous year question with solution will be covered, complete syllabus revision of first PU and second PU. Chapter wise KCET PYQ you will get in the test format, 10 full length KCET mock test you will get out of it, and please make sure you are enrolling yourself by today itself, because every day will be a doubt solving session. They will give you a structured plan towards your KCET examination. So don't do further delay, because after 25th February the price is going to be not similar as today. So yes, without further delay, make sure that you are enrolling in KC30 batch today itself. Yes, let's proceed. Okay, so here comes our numerical section. First numerical you can see. Okay, Henry's constant for the molality of methane is in benzene at 298 Kelvin is given 4.27 into 10 power 5 mm of Hg. Calculate the mole fraction of methane in benzene. So I want you people to try this out. I want you people to try this out before me, and just let me know, comment me below the answer. Okay, so how we should do actually, we know the formula. Let's say partial pressure of methane is going to be Henry's constant into mole fraction of methane. Okay, so from here mole fraction of methane I am getting partial pressure of methane divided by kH. Let's put the value, that is going to be 760 mm of Hg. 760 mm of Hg divided by, what is the value of kH here? 4.27 into 10 power 5 mm of Hg. So your answer is going to be 0.00178. yes, this one. Okay, I guess you understood this. There is no doubt about it. Let's proceed further. Okay, I can see Amaya is telling the answer. Very good. Let's proceed. Okay, calculate the osmotic pressure in Pascal exerted by a solution prepared by dissolving 0.925 gram of polymer of molar mass this in 500 ml of water at 37 degrees Celsius. Okay, what I have to do first, just let me just write down what they are saying. So volume they are saying 500 ml, right? 500 ml I can take it as 0.5 liter. Fine. Mass, weight is given how much? 0.925, right? 0.925 gram. Okay, molecular weight is given, R value is given as 8.314 into 10 cube. Okay, 10 cube Pascal, liter, Kelvin inverse, mole inverse. Okay, these are the things given over here. Okay, so now what I am going to do is I'm calculating N at first. So number of moles equals to given weight by molecular weight. What is the given weight? That is 0.925 divided by 185,000 gram per mole, right? Okay, this is the same value I'm going to put there in the equation, because pi equals to, if you write, this is CRT, right? From there you can write N by V into RT. So here in this equation I can put the value of N, that is 0.925 divided by 185,000 into volume is given as 0.5 liter. okay, into unit of R, right? 8.314 into 10 cube Pascal liter Kelvin inverse, okay, mole inverse, okay, into temperature is given something 37 degrees Celsius. You have to convert it to Kelvin. So if you can convert it to Kelvin, it will come up to be 310 Kelvin. 310 Kelvin. So if you just calculate the overall thing, it will come up something like 25.77. So now you can see everything will be cancelled out here, and the unit that will be left out, that is Pascal. So please be careful about the unit, okay? So unit will carry individually 1 mark. Individually in the sense, let's say how the marks is given, how the marks is distributed, let me tell you. For the formula itself, it's 1 mark. Substituting the proper values, it's definitely another 1 mark, and calculation with unit, that will give you 1 mark. So if even you have calculated properly but you are not putting the proper unit, then also your marks can be deducted. So please be careful about the unit. Okay, so I guess you understood this. Okay, so let's proceed further. Okay, so here comes a question. If a solution obeys Raoult's law for all concentration, its vapor pressure okay, if a solution obeys Raoult's law for all concentration, its vapor pressure would vary linearly from 0 to vapor pressure of pure solvent as shown in graph. Calculate the X. So how you should calculate the X? So here you can see, if you just find out the value here, the mole fraction, here mole fraction is coming 0.4, okay, 0.4, and at the same time, if you just look at the vapor pressure, here at that point, that you actually have to find out. Okay, so that we can take it as 1.013. So from here I can apply this formula, P equals to mole fraction of the solvent into P0, P naught of the solvent. Right, mole fraction, as you can see from the graph, it is given, it is 0.4. Now P naught for the pure solvent, always it is 1.013 bar, right? It is 1.013 bar. Okay, so vapor pressure from here I can calculate by just multiplying it. So we will get it, the answer as 0.4052 bar. Okay, just let me know if you understood this or not. Okay, I can see Amaya is giving answer, very good. Apurva, hello my dear. Okay, Jia, very good. Jia, okay. Okay, let's continue. Okay, so this is all about the solution chapter. I kept a little bit MCQ and a little bit, that numerical portion. All the theoretical questions will be covered in the physical chemistry differentiation. All the theoretical questions will be there. Okay, as of now, this is the question zone, just remember. Let's proceed. Different question related to colligative property also will be there. Okay, so yes, let's proceed. Yes, my dear, it is a model paper question. That's what from there only I have kept. Okay, let's proceed. Okay, we are going to start the electrochemistry chapter. Let's proceed further. A cell that converts energy of combustion of fuels like hydrogen and methane directly into electrical energy is known as, yes, please tell me the answer. This is going to be fuel cell, right? Let's proceed further. Among the following cells, the cell used in Apollo space program for providing the electric power, so that's going to be hydrogen oxygen fuel cell, right? Yes, let's proceed. Okay, here comes a numerical type of problem. Here you can see. So the problem is the cell in which the reaction, okay, let me just write down the reaction for your convenience. So 2Fe3 plus, this is in aqueous media, plus 2I minus, that is also in aqueous media, will give you 2Fe2 plus, that is also in aqueous media, plus I2. Okay, this is the equation. Okay, so now what can I do? I can just write down the half cell reaction to understand the N value, but by default you can understand the N value is going to be 2 here. 2 electron exchanges going on. Okay, in case you are not understanding, then you can break it down into different half cell, then you will realize it. Okay, so let's proceed with the E0 cell calculation. Okay. Log Kc we have to calculate, so we can start from the calculation that E0 cell equals to 0.0591 divided by N log Kc. Okay, so this is the formula we all know. From there we will just put the value. The value is E0 cell 0.236 equals to 0.0591 divided by 2 into log Kc, right? So if you just simply calculate this 0.236 into 2 divided by 0.0591, that is going to be log Kc. So your log Kc is going to be approximately 7.986. That is your answer. Okay, I guess it's clear to you. Yes, very good, Apurva. Okay, so if the students, you are still sitting inside the blanket, please come out of it. It's too late, and start studying. That is the only strategy that you have to follow before the examination. Okay, only keep studying. That is the only strategy. Okay, so yes, without further delay, let's proceed for the next one. Calculate the limiting molar conductivity of Cl minus ion by using the data. Okay. Okay, I can see some question. Log Kc is a constant for every reaction. Yes, because it will come as unitless. No, the value will not be similar, but it is a constant, definitely. K value is constant. Okay, it is called equilibrium constant, right? So definitely it's a constant value. Okay, for different reaction, the value will be different, right? So let's proceed. Calculate the limiting molar conductivity Cl minus ion by using the data. How should we do it? We have to apply cold rush law, right? So from where we can apply? Okay, let me just write it. Lambda m0 of, let's say, CaCl2. Okay, that is going to be lambda 0 of Ca2 plus lambda 0, 2 lambda 0 of Cl minus, because if you break down CaCl2, so sometimes I have seen students, they are doing this mistake, they forget to multiply this with 2. Why this 2 is coming? If you break it down, Ca2 plus 2 Cl minus will come, right? So this 2 you should multiply here. Okay, so from here if I just write this, lambda 0 of Cl minus is becoming something like lambda 0 m of CaCl2 minus lambda 0 of Ca2 plus divided by 2, right? Now what I have to do, I just have to put the values now. For CaCl2, what is the value? 271, right? 271.6. Okay, minus what is the value of Ca2 plus? 119.0119. Okay, divided by 2. Overall unit I am just writing here Simon centimeter square mole inverse. Okay, so if you just calculate this, your answer will come up to be something like 76.3 Simon centimeter square mole inverse. Okay. Good morning, blossoming flora. Good morning. 44 is the answer. What is why 44 will be the answer? Can you please recheck once? 76.3 is the answer. Distortion 3100 gave the correct answer. Very good. Gia, very good. Okay, let's proceed. Okay, so here comes another question. Okay, so the limiting molar conductivity of acetic acid is given using the graph, and the given information calculate the limiting molar conductivity of CH3 COOK. Fine. So for those cases, what we need actually, we need the lambda 0 value. Okay, so lambda 0 of what are the thing given? HCl and KCl. So we need lambda 0 of HCl and lambda 0 of KCl. So from where we should find it out? Okay, just look at that. This particular intercept, where that particular line, the straight line will touch, that intercept value is basically lambda 0. Right, here also intercept value you can see it is in between somewhere 125 and 175 that we can take. So 425 for this case we can take 425 Simon centimeter square mole inverse, right? That is the limiting molar conductivity, and for them 125 and 175 in between we can take 150, right? So 150 Simon centimeter square mole inverse. Okay, that is enough for us. Now what we can do, if you are just writing this, lambda 0 of CH3 COOK, for this case you can do lambda 0 of CH3 COO minus plus lambda 0 of K plus lambda 0 of, let's say, H plus. Later we will do minus as well, plus lambda 0 of Cl minus. Okay, and we can do the same thing, minus lambda 0 of H plus minus lambda 0 of Cl minus. Okay, now if you just club them properly, I can take lambda 0 of CH3 COO minus plus lambda 0 of H plus together. Okay, next I can take lambda 0 of K plus lambda 0 of Cl minus together. Okay, now minus lambda 0 of H plus lambda 0 of Cl minus, that I can take, right? So now what I can see, that this is nothing but the lambda 0 of CH3 COOH plus lambda 0 of KCl, okay, minus lambda 0 of HCl. Okay, so now what you have to do, simply you just have to put the value. CH3COOH, it's given. HCl is HCl something we got from the graph, and KCl also we got from the graph. So let's put the value. So if you put it over here, it's going to be 390 plus 150 minus 425, right? So that's going to be 115 Simon centimeter square per mole. Okay, that's going to be the answer. Just let me know if you understood this or not. Yes, very good, very good, very good. Okay, very good. Okay, so let's proceed. I can see so many of you are giving correct answer. Very good. Nice to see you people are very much prepared for your upcoming examination. Yes, with the full josh. आगे बढ़ते चलो. Okay, let's proceed. Okay, so this is a little bit numerical zone from the electrochemistry itself. Let's proceed for the chemical kinetics. So yes, so chemical kinetics, this is a one MCQ. It's taken from the model paper itself. Probably few of you have faced this in your last pre-board examination as well. So yes, so whenever this type of question will come, at first what you have to do, you have to write the rate of reaction, right? Okay, Amaya, you are saying that I am not prepared for the electrochemistry ka chapter. So electrochemistry ka chapter is not that much difficult, my dear. So basically what you can do is, my suggestion, you can just check once the one shot master stroke video of the electrochemistry. That's not that much lengthy. It's a very short video, one shot video. Okay, it's covering the entire concept of the electrochemistry that's needed for your board purpose, and then come back to the next session whenever I will take the entire physical chemistry. That time all the theoretical question, even the numerical question also, all the formulas of individual chapter, that I will also include over there. So once you just prepare in this way, I guess it will be helpful for you. So any one of you, if you are not prepared any one of the chapter of the physical chemistry or organic chemistry or inorganic chemistry, so you can proceed in this way, because all the videos are already uploaded in the master stroke. So you can just go and you can watch the one shot video, okay, and you can come back. So this is the only trick I can tell you as of now. And you know, electrochemistry chapter, it seems very hectic, but it's a very heavy weighted chapter, like solution, chemical kinetics, all the three. They are something like Brahma, Vishnu, Maheshwara. ठीक है, बहुत ही important chapter है. So please make sure that you are not cutting off any one of this chapter. And whenever it's the matter of electrochemistry, let me tell you, very selective portion you have to study. So from the basic, from the beginning, let me just tell you, first you can just start with the, you know, Faraday's first law, second law, those things you can proceed. Direct theoretical question you can get. Batteries, primary battery, secondary battery, those type of question you can get. Okay, fuel cell you can get, corrosion you can get. Then these are the theoretical, basic question I'm telling. It's not difficult. Okay, and then whenever it comes to the numerical part, definitely it focus on the Nernst equation. Okay, so majorly the question most of the time it comes from the Nernst equation. Now if you have a very bad luck, okay, then they will give you some question related to the conductance, conductivity, cell constant, all those things will be mixed up. We will do that type of problem here once, but those are also very easy, super easy in calculation. So as of now, be prepared about the Nernst equation. Okay, del G and K relation, del G and E0 cell relation, this type of formula. Okay, so I will give you the formula chart from the electrochemistry chapter as well. So don't worry, only from those formulas you can expect the problem. Okay, so that's the thing. Okay, smart riders. Ma'am, can we score 60 plus by studying this? Definitely, my dear. Now, why 60 plus better? 65 plus or 70? Everything you can get. Yes, organic question, definitely we will come up slowly. Full syllabus we will cover today. Okay, don't worry. PYQs, yeah, definitely PYQs, everything will be there, my dear. Means whenever I will go chapter wise means segment wise, physical, inorganic, organic, then definitely PYQs I will follow, don't worry, my dear. But I feel if you ask my personal point of view, your chemistry question bank that is already given, solving those, because you know MCQs are very uncertain, maybe whatever we practice, but we can predict some MCQ that yeah, this type of things can come. So that idea you can get only solving the question bank and the model paper that is given to you, 3 model papers. So make sure that you are doing it properly. So I am also focusing on them. Okay. Yes, Gaura, ma'am, are you Bengali? Yes, my dear, I'm Bengali. Fortunately, unfortunately, I don't know, but yes, I'm Bengali. Okay, let's proceed. For the reaction 2A plus 3B plus half C gives P, the correct rate of the reaction. So, what do you have to do? What do you have to do? You have to just write the rate of the reaction at first. So, yes, rate of reaction, ROR. So, how you should write? Minus 1 by 2 dA by dt, okay, equals to minus 1 by 3 dB by dt equals to minus 2 dC by dt. I'm not writing the product anymore because it's not included in the options. Okay, so now if you just simplify this in accordance to the option, it will come something like d of a dt. Just multiply these two here, equals to minus 2 by 3 dB by dt, right, equals to minus 1 by 4, okay, dC by dt. Okay, so sorry, minus 4 it should be. So minus 4 dC by dt. Yes, so if you just check, option A is going to be the correct one. Okay, so let's proceed. I can see Arun Kumar. Is this enough to get 70? Yes, my dear. Yes, my dear. It is enough, more than enough to get 70. Don't worry about it. I'm not covering the 2-3 marker theoretical question here. Okay, so definitely you need the theoretical questions as well. So I'm just covering the MCQs and I'm broadly focusing on the numerical type question here. Okay, so yes, so in that particular case, let me just tell you, whenever I will come up with the physical chemistry different section, then the 2-3 marker along with numerical will come. Okay, so that will be more than enough. Okay, so yes, let's proceed. Okay, this type of question, this is called initial rate method, by which we can solve this type of question. You can see here are datas given, means whenever the concentration of this, concentration of B is this, rate is this, like that the datas are given. Okay, so what you have to do, you just have to find out the order of A with respect to A and with respect to B. Okay, and then you have to put them in the rate equation. Okay, so what I have to do, I have to just first write the equations, right? So okay, let's write the equation at first. First equation, see, in general the equation is rate, I guess you can see, no, it's not visible, wait, let me write it here. Rate equals to K into A power X B power Y. Okay, so for this particular case, what you have to do, write the equation one by one. 6.0 into 10 power minus 3. 10 power minus 3 equals to K into 0.1 power X into 0.1 power Y. Okay, this is your equation number 1. Next, 7.2 into 10 power minus 2. 10 power minus 2 is basically equals to K into 0.2 into 0.3 power X and Y. This is your equation number 2. One more equation, 2.4 into 10 power minus 2. 10 power minus 2 equals to K into 0.1 power X into 0.4 power Y. That is your equation number 3. Okay, next, 2.88 into 10 power minus 1. 10 power minus 1 equals to K into 0.4 power X into 0.3 power Y. That is your equation number 4. Now you have to arrange this equation in such a way, so that you can find out the value of X and Y. So how you should do it? So first let me just proceed with Equation 3 divided by 1 we can do. Equation 3 divided by 1. Okay, so if I do this, that is 2.4 into 10 power minus 2 divided by, please do with me you people as well, 6 into 10 power minus 3. K will be cancelled out. I'm not writing this. 0.1 power x into 0.4 power y divided by 0.1 power x into 0.4 power y. So from here if you just calculate, it will come up to be 4. That also will be something 4. This is 1, sorry. That is also will be 4 power y. So if you compare the power, y will be equals to 1. Okay, in the similar way you can calculate the x as well. So let's calculate the x. Let me just calculate here. I guess it's visible. So what I can do to calculate x? Let me do 4 divided by 2. Okay, let me do 4 divided by 2. Okay, so if I do 4 divided by 2, it will be something like 2.88. 2.88 into 10 power minus 1 divided by 7.2. 7.2 into 10 power minus 2, right, equals to, I'm not writing the k, 0.4 power x into 0.3 power y divided by 0.2 power x into 0.3 power y. So y term will be cancelled out. From here almost you can get 4 and here you can get 2 power x. So 2 square equals to 2 power x. From here I can get x equals to 2. Yes. So now if I want to write the overall rate equation, it will be something like k into a power, k into rate equals to k into a power 2 y power, b power 1, right? So option C is going to be the correct one. Okay, I guess it's clear to you. Let's proceed. Okay, okay, definitely I will make sure that next time I'm using the blackboard. Okay, I can see a few of you are giving answer C. I guess it's clear to you. Let's proceed further. Okay, so here a question: for a reaction 2NH3 in presence of platinum catalyst, it will give you nitrogen plus hydrogen. Okay, so for this, what is the rate equation? So let me just tell you, my dear, for this type of case, whenever they will ask you this type of equation, means any equation decomposition of gas is taking place on a metal surface. Okay, here they are giving the decomposition of ammonia gas. Sometimes they can give you the decomposition of HI to give you H2 plus I2 on gold surface. Okay, any decomposition of gas on metal surface will be zero order reaction, Who is saying? Experimental fact. Okay, it's shown experimentally. Okay, so if NH3 power 0 means 1, right, because it is a zero order reaction, hence your answer is going to be option D. Okay, no my dear, 7 is not going to be C. Who said it's elementary reaction? Is it mentioned here? No, it's not mentioned here. Then how can you say that it's the stoichiometry will go to the power? You can't say like that. The answer is given here, platinum catalyst, metal surface. Okay, be careful about it. Any reaction, whenever it's going on a metal surface, decomposition of the gas, okay, whenever it is going on a metal surface, then it is a zero order reaction. Just let me show you this reaction. 2HI will give you H2 plus I2 without any catalyst. If you just proceed with the reaction with normal heat, it's a second order reaction, my dear. The rate is basically K into HI square. HI square, it's a second order reaction. But if you see 2HI is giving H2 plus I2 and they are mentioning AU surface. That is the answer. That is the answer, my dear. Then it will be rate equals to K into HI power 0. Something power 0 means 1. I guess it's clear to you, my dear. Let's proceed. Let's proceed. Okay. This is a numerical. Okay, no, not a numerical type, but it's an important question. Okay, for the reaction H2 plus I2 gives 2HI, draw the diagram showing the plot of potential energy versus reaction coordinate to explain the role of an activated complex in a reaction. Okay, so I can see Naveen. Ma'am, is this our board related questions only? Na ma'am, the questions you given for midterm and pre-boards are only came to exam. Is this for the annual exam, ma'am? Yes, definitely, my dear. It's for the annual examination. So yes, definitely. Again, I'm telling you, my dear, today in this live session, I'm trying to cover the entire syllabus. So I'm only focusing on the most important MCQ and majorly numerical problems. Okay, yeah, physical chemistry I will proceed with some numerical problem. Theoretical question I will avoid. Definitely, whenever it will come to the inorganic, I have to proceed with some theoretical problems, and then inorganic a little bit reaction mechanisms and all I will proceed with. Okay, but if you want to get the theoretical question, make sure that you are watching the physical chemistry entire session. Okay, so let's proceed. Different color pen. Okay, so you have a different demand. What should I use? I should use green. Okay, let's see. Okay, let's proceed. Let's proceed for the reaction. Okay, so how you should proceed? I guess it's okay for you now. I don't know how it's looking in the camera. Okay, anyway, so any reaction whenever you are going to start, the reactant and this should be the product. Okay, in general it's an exothermic case. In general, like how I know it is an exothermic case, because in general if the reactant is stable, then why it will go towards the product, right? It should not go. So in general what we do, we keep the reactant little up and product little stable. Means when reactant is going towards the product end, it will get some extra stability. Okay, that's the urge of a molecule, that is to get stability. Everyone in the universe, they are looking for the stability. Why not this molecule? So that's the reason reactants are top, products are below. So here I am having H2 plus I2. Okay, so how they will go here, and here I am having the product HI. Okay, how they will go here? Like this? No, my dear, they will not go like this. Rather, they will follow a different path like this. Okay, so why they are following this much path? Okay, means whenever I can go like this, I'm following a hill station route. Why this? This is because the new bond making and old bond breaking, it requires some amount of energy, and that particular energy is called energy of activation. The energy that is required to reach at the hill station, it's called, at the top of the hill, is called energy of activation. Okay, so now here at the top, the complex that is formed, it's neither reactant nor the product. It's neither reactant nor the product. It's in between reactant and product. This is called activated complex. Here what we get? We get activated complex. Okay, and this particular state is called transition state. Okay, here it is neither reactant nor the product, very unstable. The valency is not same. Okay, very unstable. So once you give the energy, once they will attain in this amount of activation energy, they will reach the activated complex form in its transition state, then just simply coming down to the product formation. So this is the potential energy. This is definitely, it's going to be potential energy, and this is RC, reaction coordinates. Okay, versus reaction coordinate diagram. And please make sure that you are writing at least 2 lines about the activated complex. You just mention it is energetically very high. It's neither the reactant nor the product. It's a state in between. Okay, and it exists in the transition state where the activation energy is high. Okay, so this much will be enough. Okay, Pradyun, very good, very good. Pradyun, explain me what is the activation energy. Okay, very good. I guess it's okay, it's clear to you. Let's proceed. Okay, so here comes the numerical problem. Okay, so let's proceed. The first order rate constant at 600 Kelvin is given, and the energy of activation is given this. For a reaction, calculate the rate constant at 700. Okay, whenever you will see 2 different temperatures are given, and whenever you will see that rate constant you have to calculate with respect to the new temperature, then एकदम आंखें बंद करके Arrhenius rate equation स्वाहा, like that. Okay, so make sure that you are writing the Arrhenius rate equation properly, Arrhenius equation properly, because that will itself give you 1 mark. Okay, and proper substitution will give you another 1 mark. So why to waste 2 mark? Maybe I'm doing some mistake in the calculation and in the unit. Okay, so make sure you are at least securing 2 marks out of it. Okay, let's proceed. Okay, so what is the equation? Log K2 by K1 equals to, question answer same ink. Okay, let me just change it. EA divided by 2.303 R 1 by T1 minus 1 by T2. Okay, so yes, let's put the value here. Log K2 we have to find out, right? K1 is given. Okay, so yes, let's put K2 we have to find out. K1 is given something like 2 into 10 power minus 5 second inverse. Okay, here activation energy value is also given. Kilojoule is given, be careful. I will convert this thing into joule. So I will get it as 209,800. Yes, 00 joule per mole. Okay, divided by 2.303 into R value is 8.314 Kelvin joule per Kelvin per mole, right? Here temperature if I put 1 by 600 minus 1 by 700. Okay, Kelvin. Just let me know if you understood this substitution or not. So if you just calculate this entire thing, let me just proceed. Log K2 divided by 2 into 10 power minus 5 second inverse. Here I am having 209,800 divided by joule will be cancelled out, mole inverse will be cancelled out. From here I will be having only Kelvin 2.303, and here I will be having something 700 minus 600 divided by 600 into 700, right? If I am doing any mistake, please let me know, make me aware of it. Okay, I guess it's clear to you. So from here, if I just calculate this thing, log K2 by 2 into 10 power minus 5 second inverse. If you calculate this side, it will give you something. Let me tell you. You will get something 6.008 divided by 2.303. Okay. So now if you just take the antilog of this and if you calculate it for K2, I'm just going back to the final answer. Antilog means 10 power something you have to proceed with. So your final answer will be something like 0.0008135 second inverse. That is the answer for the K. Okay, I guess it's clear to you. Just let me know. I guess it's clear to you, my dear. Okay, yes, guys, is it for state syllabus, Zainab? Yes, definitely. It is for state syllabus. R I calculated here itself, okay? So whenever just I multiplied this thing, no, 700 minus 600, this entire thing when I multiplied, here I forgot to write, fine. Then I just included R here, okay? So overall calculation. I guess it's clear. Let's proceed. I'm just not going to the detail, like if you just divide this thing antilog you do, okay, and then just multiply with 2 into 10 power minus 5. That's it. Okay, let's proceed. Okay, this question. So yes, what they're saying, analyze the given graph drawn between concentration of reactant in mole per liter versus time in minute. Calculate the average rate of the reaction in terms of minute and second. It's going to be a super easy one. So average rate, what is the formula? At first you tell me. Average rate is basically equals to minus delta R by delta T, means delta R means R2 minus R1, R2 minus R1 divided by T2 minus T1. Now here I just have to put the value, nothing else. What is R2? Okay, so here you can see R2 value I can write as okay, 0.4, right? 0.4, right? Minus initial is 1.6, right? Here, right? 1.6 divided by I can write T2 is basically 20. For 0.4 it is 20, right? Minus initially time was 0. So now if you just calculate this, it will come up to be 0.06 mole per liter per minute. Right? Now if I just convert it into second, that's going to be 0.06 divided by 60 mole per liter per second. Right? So it's going to be 0.001 mole per liter per second. Okay, I guess it's clear to you. Just let me know if you understood or not. Okay, let's proceed. Beta, how it is coming? Minus it should not come, okay? Distortion or something, 3100. Difficult name you people keep. Anyway, let's proceed. I guess you understood this. Yeah. Okay, one more question. You can see it is taken from the model paper. Okay, let's proceed. A first order reaction has half-life of 23 minutes. Okay, how much time will be needed for 30% completion of the reaction? It's a very important type of question. It's Please make sure that you are doing. Okay, so what I can do is, we know K is basically 0.693 divided by T half, right? So here I can put the value 0.693 divided by 23 minutes, right? So this will give you the K value as 0.03013 minute. Okay, now what you have to do? Integrated first order equation, T equals to 2.303 divided by K into log A0 by 80. Okay, so now if you just put the value, everything, 2.303 here divided by K value is 0.03013. Okay, log, okay, here A0 I can take 100, so 30% completion, right? Means how much is left? 70. Okay, so if I just further calculate this thing, I will get it as this thing will come up to be with 2.303 divided by 0.03013. This will come up to be log 1.42. Okay, so log 1.42 it will come, so it is lesser than that of 0.3 value. Okay, so if you just calculate this thing, no, your entire answer will come up to be something like 11.84 minute. Okay, I guess it's clear. Okay, how to take R2 and R1. Okay, so here you can see, for this particular case, you can see, see 30 seconds is the ending of the reaction. Okay, so for this case, just take any one instant you can take, any one instant. Means let's say I'm just targeting this one. You can target this one, anything. Okay, so for this case, if I take this one, so this will be my R2, and R1 means it's the beginning, right? R1 means from where I started, right? So for this case, I am having 20 minutes, right? So with that respect, 0.4 minus 1.6, and with respect to 0.4, the time was 20 minutes, and T1 was beginning. It's not yet started. I started with 1.6, so it is 0. Right? So now if you just calculate simply, it will come up. Okay, so here how 6.008, where my dear 6.008, where 6.008 my dear, can you please explain where? Okay, I guess this case, last to last. Okay, so basically if you just calculate this entire part, this thing, wait, let me just mark it for you. Let me mark with white. If you calculate this entire part except 2.303, it will come 6.008. Okay, just calculate this. I have calculated this, it came to be something like 6.008. If it is not coming, then just let me know. I guess it's okay. Okay, let's proceed. Okay, next, a very important question you can see, 3-marker question, anyone, either 0 order or first order, any one of them is important. So let me just derive for you people integrated rate equation for the 0 order and first order. Okay, so first I will start with the, let's say I'm having A will give me the product. Okay, so Fawzia Sultana, just let me know if you understood this or not. So for this case, let me just write ROR, rate equation, differential rate equation, that's going to be minus dA by dt. Let's say this is my equation 1. Next I will write the rate law, right? That is k into a power 0, because it's a zero order reaction. Let it be equation number 2. Now equating 1 and 2, equating both of them, what I will get, this is minus d of a by dt equals to k into a power 0, right? So this is going to be d of a, just a little bit arrangement if I do, equals to minus, okay wait, let me change the side, that's going to be minus k of dt, because a power 0 means 1, right? Let me just proceed here further now on integrating both sides. So what I do while integrating itself, I put the limit, okay? The same thing you can do as well, dA equals to minus k outside of dt. Now whenever t equals to 0, the concentration of A is A0. When t equals to T, some random temperature, A will be AT, right? So from here I can get AT minus A0, AT minus A0 by putting the limit equals to minus k into T, right? This is something I will get. So now if I just change the sign, A0 minus AT equals to KT. So you can just get it something like this. So K is basically equals to this, right? I guess it's clear to you. So one more thing I just wanted to tell from here itself, from this case. Okay, so the graph is very much important, so little bit just let me explain about it. So from here I can get AT is basically equals to minus KT plus A0, right? You can say this is a straight line equation, right? This is your y, minus k is your m, this is your x, this is your c, y equals to mx plus c. If you want to plot the graph, so AT versus what graph you are plotting, it's very important my dear. AT versus T graph, okay? So it will give you something like this with an intercept of A0, and the slope value out of it, it will be minus k. I guess this thing is clear to you. Please let me know, you people. Okay, so let's proceed further. Let's proceed with the first order reaction. Okay, so whenever it comes to the matter of last part, please explain. Okay, definitely I will explain. I guess the graphical part you want, the graph you want, my dear. Okay, so here you can see from this equation, this particular what I made it in the box, that is for your numerical purpose. Using this you can proceed with the numerical problems. Okay, just one step ago, this particular step you can see, from here I can write AT, just changing the sign. Okay, AT I am taking this side, A0 I am just taking that side, so plus A0, right? So it is resembling to the straight line equation. What is the straight line equation? Y equals to mx plus c, right? If it follows this type of equation, then we can say the graph will give you a straight line. So you can see this is your y, minus k is your m is slope, okay, t is your x, and a0 is your c. It looks like that. Okay, if it resembles to this equation y equals to mx plus c, then we can say it is a straight line. Okay, it resembles to this equation, right? So that's the reason I can take this thing. Okay, so now if I want to plot this, AT will be in the y-axis. In the x-axis, I will be having T. Okay, as the slope is negative, so graph will go towards negative zone, I mean towards below, right? So the straight line is going towards below with the intercept A0. Okay, intercept means where it touches the y-axis. Okay, I guess it's clear to you. Let's proceed. Yeah, let's proceed. Just let me know, Gia, if you understood or not. Okay. So yeah, let's proceed with the first order integrated equation, blossoming flora. Okay, already you are telling me. Okay, let's just simplify this thing as well, and we will come up with so many graphs out of it. Let's see. Okay, so ध्यान से देखना. Okay, be patient and just watch it. So I can start from A will give you the product. Okay, rate of reaction I can write dA minus of dA by dt. This is my equation number 1. Okay, and rate can be written as k into a power 1, right? This is your equation 2. So equating both sides, what I can get? Minus dA by dt is basically equals to k into a, right? So from there I can just adjust the side, dA by a equals to minus k into dt. Let's integrate. On integrating both sides, what you can get here, t equals to 0. When t equals to 0, a will be a0. When t equals to t, a will be at, right? Okay, so now what I can get out of it? Here, if you do dx by x integration, it will give you ln of x, right? So from here also ln of at will get ln of at minus ln of a0 equals to minus k into t. Okay, from here itself I can draw the graph. Okay, from here itself I can draw the graph. Let me show you. For this equation, if I just rearrange a little bit, it will give me ln of, okay, Gia, please be conscious. Here I am going to do the same thing. Ln of at is basically equals to minus k into t into ln of a0 plus ln of a0, right? Okay, so this is, again you can see, this is your y. Okay, minus k is your m, right? T is your x, and this is your c. So if I want to draw a graph out of it, what I have to do? I have to keep y-axis as ln of at. Okay, and x-axis I can take it as t. The graph will be something like this. The slope will be minus k, and here it should be, the intercept should be ln of a0. So what versus what graph? It is ln of at versus t graph. So one thing you need to remember, for zero order reaction, at versus t graph will give you slope minus k. 80 versus t graph. But for first order reaction, ln of 80 versus t graph will give you slope minus k. Okay, this is a very important point to remember. For zero order reaction, 80 versus t graph will give you slope minus k, but for first order reaction, ln of 80 versus t graph will give you minus k. Okay, I guess this thing is clear to you. Let's proceed. A little bit further we can proceed. See, from here I will continue. Okay, from here I will continue. Okay, so what I can do is, I can take log, I can make it, I can just convert it to log. So 2.303 into log of 80 minus log of A0 equals to minus KT. Okay, this thing further on rearrangement will give you log of AT equals to minus K by 2.303 into T plus log of A0. Okay, see, I have changed this into the log and hence the slope value will be changed now. So this is my y-axis. This minus K by 2.303 is now M. This is your C. Sorry, this is your X. This is your C. Okay, now again if I just put this thing into the graph, okay, it will give you something like this type of thing. Let's say log of AT, here y-axis is log of AT, be careful, log of AT versus T graph, right? It will give you again this type of graph, okay, with the intercept value log of A0. Okay, so here the slope value will be, whenever you are using log, the slope value will be minus K by 2.303. Okay, I guess it's clear to you. Okay, one more step ahead. Let's do. This is your equation, okay? This is your equation, you can keep it like that. Okay, one more step ahead if I just proceed. So, log AT by A0 I can write. Log AT by, okay, let me just change the sign for you people. It will be easier for you. Log A0 minus log AT, right, equals to KT by 2.303. Okay, from here I can write log of A0 by AT equals to K by 2.303 into T. This is also a straight line equation, my dear. It's very important, huh? It's very important. I have seen question coming out of it, this thing. Okay, but here the intercept is coming 0. Nothing is there means I can take it as 0. So, sorry. So this is my Y. This is my Y. Okay. This is my M. This is my X and this is my C. Okay, so if you are using this type of graph, means I am using log A0 by AT, log A0 by AT in the y-axis, log A0 by AT in the y-axis. Okay, check the axis, log A0 by AT. X-axis I am using T. Okay, the straight line should pass through the origin with the slope value equals to K by 2.303. Okay, very important thing. Okay, remember the last case. In case you can take it from the ln as well. Okay, from the with respect to ln of A0 by AT also you can do. For that case, K by 2.303 will not come. Slope will be equals to K only. Just let me know if it is clear to you or not. The last case. Okay, all the possible graph I told you, this one and that one. Just let me know if it is clear or not. Okay, let's proceed. Okay, very good. Jia, Naveen, Pradyun, very good. Okay, let's proceed. Okay, one more problem. It's a very important problem. It's taken from the model paper. I guess in the pre-board also same problem I guess you got. Okay, let's see. Okay, the problem says carbon 40 content of an ancient piece of wood was found to have 3/10 of that living tree. Calculate the age of that piece of wood. Okay, so any kind of radioactive decay follows the first order kinetics, right? So with respect to that we can just proceed. My equation wait. Equation is something like n of t is basically n0 into e power minus lambda t. Okay, this is the equation. Okay, where lambda is basically equals to the decay constant. Okay, so now if I just proceed, okay, they are saying half-life, okay, log 3 value is given, fine, chalo. So lambda is basically equals to 0.693, the similar way we find out the half-life equals to t half, right? So now t half is given, right? That is 5730, half-life is given, right? From there I can put the value here. Okay, lambda equals to 0.693 divided by 5730. Now one more thing, n of t by n of 0, that is also given 3/10, 3 by 10, right? So from there if you just put the value here in this equation now, so 3 by 10 is basically equals to e power minus lambda into t. Okay, don't get confused, I will take log both side, ln I will take so that e gets cancelled out. Okay, so I will take ln at first, I will convert it to log definitely. 3 by 10, this is going to be minus lambda into t. Lambda value I will put definitely. Then let's convert this thing. Take log. Okay, so 2.303 log 3 minus log 10. Okay, equals to minus lambda t. Fine. So from here I can get 2.303. If I just put the value 0.47 minus log 10 is 1, right? Equals to minus lambda t. Fine. Now just simplification. That's it. So if you just simplify this portion, it will come up to be minus 1.204. If you just simplify this side, is equals to minus lambda by t. Okay, so from here I am getting lambda t is equals to 1.2040, because same sign both side negative, we can cancel out. Okay, so now let's put the value of lambda here. Lambda is basically 0.693 divided by 5730 into t is 1.2040. Fine, let me just calculate t here. T is going to be 1.2040 into 5730 divided by 0.693. If you calculate this, you will get the t. So if you calculate this, your answer will come up to be something like 9958.6 years. Okay, just let me know if you understood this thing or not. Okay, explain the question. Okay, let me just tell you, they are saying that a C14 content of an ancient piece of wood. Okay, C14 means carbon dating, right? It follows the radioactive decay method, right? It was found to have 3 by 10th of that of a living tree. Okay, means that particular content, it's a very old one, that is 3 by 10th of a living tree. Okay, now calculate the age of the wood piece, means how aged that old, how old that wood piece, that you have to find. So for those cases, for radioactive decay, we follow this equation. N of t equals to n0. N0 means the original time, is e power minus lambda into t. Here lambda and the rate constant is quite similar, but their k is called rate constant, here lambda is called decay constant. How it is coming? It comes in the similar way, the way you calculate the first order integrated rate law, but not needed. You don't have to remember the derivation, just remember the form itself, because this problem is very important. Okay, remember this form only. Okay, lambda is the decay constant here. Okay, so how I should calculate the lambda then? Rate constant, how we calculate? Half-life is given, you can see half-life is given 5730. Right, so once half-life is given, we know first order reaction. What is the formula of half-life? K equals to 0.693 divided by T half. Here also the same thing, lambda equals to 0.693 by T half. Okay, if you just put the value, I just put the value like this. Okay, I am not doing anything, I didn't do the calculation, I did the calculation here. Okay, now NT they are saying N of T, the time of that ancient T, it's 3/10th of the original piece, right? That's what they're saying. From there, NT by N0 I can write 3/10, right? NT by N0 I can write 3/10 from here, right? So that's the same thing I'm putting here in the equation further. Okay, from this equation NT by N0 I'm putting 3/10 into e power minus lambda t. Now if I take lambda both side, I mean not lambda, sorry, if I take logarithm, natural logarithm you have to take because it is e. So ln I have to take. Now the calculation is similar. Ln I have converted it into log. Log if you convert, then you have to multiply this thing with 2.303. Okay, so now if you just simplify the calculation, you will end up with this type of thing. Put the lambda from that equation, from here, just put the lambda value over there. Okay, so once you just put the lambda out of it, then just T you have to calculate, that's it. Okay. Okay, the value you are getting 10252. No, my dear, just calculate this properly once. It should be something 99 something. It should get, you should get 99589, close by value. Okay, it's okay. Okay, so I guess you understood. Just whoever was having problem, Dhanush and blossoming flora. Can you please tell me if you understood or not? Whenever you are converting ln to log, you have to multiply this thing with 2.303. It's the rule, because ln represent natural logarithm and log represent base 10. Ln base e, ln is with respect to base e, log is with respect to base 10. You are converting, so you have to multiply this thing with 2.303. Okay, very good. Let's proceed. I guess it's clear. Okay, Shahin, ma'am, if we solve important questions, is it enough to score 70? Yeah, definitely. See, full year you will not study anything. At the end moment you will ask me this question, ma'am, is it important if we solve the important question? Yeah, definitely. You by heart the important question, my dear. Okay, so anyway, today it's an overall recap of the syllabus. I guess it will be more beneficial for you when I will do it segment wise. So make sure that you are joining that sessions or you are just watching the videos. Okay, so let's proceed with the further problem. Okay, D and F block element. Here you will see the theoretical problems majorly. Okay, I will just tell you an overall view. Let's proceed. Okay, with a little bit MCQ. See, this question is taken from the model paper. Okay. The common oxidation state shown by the element with atomic number 21. 21 is scandium. So scandium, if you just see, this is 3D1, 4S2, right? So if you just remove this 1 and 2, so it will be scandium 3 plus, means it is 3D0, right? Means it is a P6 like configuration. P6 like configuration is very, very stable. So most stable oxidation state is going to be +3. Pradyun, both +3 and +4. No, +4 it will never form, my dear. Okay, why +3 it will never form? Why +4? Because once it will form the +6, I mean +3 oxidation state, it is already P6 configuration, my dear. Why further it will release one more electron, right? Okay, so Pradyun, just let me know if you understood or not. Okay, ma'am, I'm not getting the first. We should solve the important question and then textbook to be glance. I'm unable to manage. Please help me out from this doubt? What you didn't understand that that I didn't get actually? So my dear, important question is definitely important. Definitely you should proceed with. It's something you must do, but definitely a little bit conceptual clarity you need, right? So yes, this is not a good time to go through the textbook. This is a time to practice, my dear. So that's the reason I kept an interactive session, so that I can communicate with you people. You people will answer me, I will answer you. You will see how I am solving the problems. So that is the thing. Okay, so okay, first important questions to be read from the textbook. Yeah, you can read from the textbook, or else the way I told you, physical chemistry, inorganic, organic, different segment wise video, it will come very soon. That's what I have planned. Their theoretical question, all probable theoretical questions will be there. Okay, so yes, answers will be there, so you can go through from there as well. You can follow your GWith, you can follow the question bank. Okay, NCERT exemplar for the MCQ purpose. Okay, it will be more than enough, I guess. Okay, let's proceed. Yes, very important question, very important question. I guess if I'm not wrong, it came in your examination. No, it didn't come, sorry, it was something else. Okay, match the following transition metal compounds with their catalytic activity in the corresponding process. Okay, so I'm starting from the last. Okay, vanadium pentoxide, it is contact process, right? B. Nickel, it is for the hydrogenation of fat, right? D. PDCl2, okay, PDCl2 is for the Waker's process, right? A. And this is TiCl4 and trialkyl aluminium. This is basically your Ziegler-Natta catalyst, right? Ziegler-Natta catalyst. So this is used for the polythene manufacturing. Okay, so 1 is going to be C, 2 is A, 3 is D, 4 is B. Okay, same answer. A and B both are correct. Okay, I guess it's clear. Let's proceed further. Yes. Which of the following elements in liquid in the normal temperature? I don't have to tell this. I guess you know it's mercury. Let's proceed. Oh, where are you people? Give answer. What the hell are you doing? I don't know. Don't waste time. Come out of your blanket. Come up with the full josh and participate. Okay, statement 1, potassium permanganate is a powerful oxidant. Statement 2, KMnO4 oxidizes I- to IO3- in acidic solution. Okay, first statement is definitely is going to be true. That is, potassium permanganate is a strong oxidizing agent, yes. But KMnO4 oxidizes I- to IO3- not in acidic solution, in alkaline and neutral solution. Okay. In acidic solution, it oxidizes I- to I2. Iodine is liberated. Okay, so statement 2 is going to be the wrong one. Statement 1 is correct, statement 2 is incorrect. So option D is going to be the correct one. Okay, see, so many wrong answers are coming. Statement 1 is correct, 2 is incorrect. Okay, I guess you understood this. Very minute difference from here question comes, my dear. Acidic solution. If your solution is acidic, I- will be converted to I2. And if the solution is neutral or alkaline, I- will be converted to IO3- iodate. Okay, let's proceed. It feels like I am having more josh than that of you people, because you are having exam. It feels I am more worried than you people. Okay, let's proceed with the next one. Electronic configuration of a transition element X in +3 oxidation state is Ar3d5. What is the atomic number? Tell me, my dear. Tell me. First. I want you people to answer. 14. What is atomic number? Okay, so +3 oxidation state. Add 3 more electron with this. So 3d5. Okay, so +1 electron. So it should be 3d6, 4s2, like this, right? 3d6, 4s2 means 26. 26 is which element? Tell me. Which element has atomic number 26? Yes, tell me. This is iron. Yes or no? Okay, very good. Let's proceed. What is lanthanide contraction? Mention two consequences of it. Very important question, my dear. Lanthanide contraction is what? Because of the poor shielding of D and F orbital, we will see a gradual decrease in the atomic radii, right? As we move down to the group. That is called lanthanide contraction, right? Sorry, move with the period, right? Move with the period, and we can see this chemical similarity as well in the group, right? So this is called lanthanide contraction, right? Okay, and two consequences of it. This is the definition, proper definition I want you people to write, and the consequences, you can see three consequences I have kept here. Similarities in size of 4D and 5D. Okay, we will see chemical twins out of it, zirconium, hafnium, just after the lanthanides, right? Similar atomic radii, sometimes it becomes difficult to separate zirconium and hafnium from their ores. Okay, next is difficulty in separation, I already told you with the same thing. And another one I can just discuss about increased density because of the decrease in volume. Okay, I guess it's clear. Let's proceed. Okay, how many square pyramidal units present in decacarbonyl dimanganese 0? Write the molecular and structural formula. What is the molecular formula? Decacarbonyl dimanganese 0. Okay, Mn2 CO whole 10, right? This is the formula, right? Okay, so basically if you draw the structure, two square pyramidal units are attached. Let me show you this thing. Okay, so here if you just connect this is the tip. Okay, if you let me show you. If you just connect this, okay, if you just connect this, you can see this is a square pyramid, and here also this is a square pyramid. This is a square pyramid. Okay, two square pyramidal unit, they are connected. Okay, this is the structural formula of it. Okay, so how many? This is 2. This type of question is something that, you know, you need to know this. Like, it's not something like, oh, I don't know, I can be a poet, I can make it, I can make a new thing out of it, I can discover a thing. No, it's not possible in this type of problem. So once, be careful if you are going to attempt this type of question. See, you will be having options, right? In case you know, you are sure about it, then go for this type of question, otherwise leave them. Okay, don't go to attempt these questions. Okay, yes, Shahin, please reply. Okay, ma'am, if read Jivit publication is enough to score 70 marks, if I read that full means, please reply. Okay, yeah, Jivit publication is definitely good one, but beta, are you sure that you can really by heart the entire Jivit? Because I guess it has quite similar thickness than that of NCERT, even more, I guess. Okay, so make sure that you are following the target zone. Okay, understand the zone from where the question is coming. Otherwise, don't do hard work, do smart work. Okay, so that's the reason whenever the class is going on, I'm just targeting a fixed zone, not all the thing. Okay, so that's why you have to be smarter enough. Okay, very good. Then if you have read this 2 times, then very good. Okay, so again I can see one question. I couldn't pronounce your name, I'm sorry. This pink DP. Okay, is this question in this video is enough to score? Yeah, the numerical problem and whatever I will discuss about the inorganic and organic, those will be more than enough. But few question, theoretical part, again I'm telling you from the theory, physical theory part, that I will discuss in the 2-3 marker physical chemistry separately. Please make sure you are watching that video. Those are for the physical purpose. Okay, physical question, theoretical purpose. Okay, so yeah, let's proceed. Here you can see these type of problems are very important, my dear. Potassium dichromate and KMnO4 related, whatever is there in your NCERT or whatever is there that you know, go through it, my dear. Okay, because that's going to be important. Okay, so for this case, what will be here? Tell me, my dear. first case, this is your chromite, right? What is the formula? Who will tell me? Who will write the formula? Okay, okay, blossoming flora, you have tremendous preparation. Very good. Okay, so this is going to be FeCr2O4, FeCr2O4. Here, as you can see, to balance it, I am just multiplying this with 4. Okay, and for this case, you tell me, if MnO2 is fused with KOH, what you are going to get? You will get K2MnO4, right? K2MnO4 plus O2, right? Next, if KMnO4 you heat, if you heat KMnO4, you will end up with K2MnO4 plus oxygen plus MnO2. Okay, I guess it's clear. Yeah, let's proceed further. Let's proceed. Okay, write the balanced chemical equation involved in the manufacturing of the potassium dichromate. I told you any one of them definitely is going to come, either this thing, I mean potassium dichromate, or it is KMnO4. So this is the entire thing. I'm not explaining. First you have to roast this with Na2CO3, the way you roast people. Yes. Then it will form sodium chromate. In presence of acid, it will give you sodium dichromate. Then further you treat this with KCl. It will give you K2Cr2O7. Okay, let's proceed. This is explain the preparation of KMnO4. Here you can see, if you just treat the MnO2 with KOH, you will end up with K2MnO4 and water, right? Next, K2MnO4 on being treated with water will give you KMnO4 plus MnO2 plus KOH back. Okay, now if MnO4, already I discussed this reaction there, KMnO4 is further heated, you will end up with K2MnO4 plus MnO2. Sometimes they ask what gas you will get. See, mention the gas evolved, O2 gas. Okay, I guess it's clear. Yeah, let's proceed. Coordination compound. Okay, let's do first question. Manganese with Cn6 3 minus and FeF6 3 minus are the inner orbital and outer orbital complex. So inner orbital and outer orbital complex, how you will understand? Check the ligand. Okay, so here the ligand is cyanide, and next case it is the fluoride, right? So cyanide is a strong filled ligand, right? Cyanide is a strong filled ligand, so it helps, or it actually forces the electron to pair against the Hund's law. I will show you one example. I will do this with you. So cyanide will force the electron to be paired up against the Hund's law. So it will utilize the inner d orbital. So once the inner means n-1th d orbital will be used, you can call it inner orbital complex. But whenever it comes to the matter of fluoride F, right, it's a weak filled ligand, right? So weak filled ligand, this basically will not force pair the electron, so it will utilize the outer d orbital, nth d orbital. So definitely it's going to be option A, inner orbit and outer orbit complex. Okay, very good. Let's proceed. Okay, this is a question taken from your model paper. Okay, so this is basically, if you know the spectrochemical series for the ligand, then it is easier for you to understand. First it comes Cn minus, then it comes, what are the ligands are given, then it comes water. After that you can take as F minus. Okay, then you can take Cl minus. So now tell me what's going to be the answer. The answer is going to be, okay, arrange the following complex in the increasing order of the crystal field splitting. So definitely this is the strongest field ligand. So strongest something, if it hits the metal, it will result the maximum splitting. So this, then H2, then Cl, then F. Option D is going to be the correct one. Option D, distortion. What is the meaning of distortion? Dy. I guess it's clear. Just let me know. Okay, so let's proceed. Okay, it's just a name. Okay, just a name. Very good. One more thing, just sharing with you people. It's not something like I want more follower. Just a sharing. I also have something such a name in some of our social media. I will not take the name. It's something unpaired electron. Okay, so as you told, just a name. That's why I also shared. It's just a name, unpaired electron. Okay. Yeah, F comes before Cl. Yes. That only I did, no? Okay, so, oh, wait. F comes before Cl. So, is there any other option with Cn? Okay, option A is going to be correct one then. Okay, I missed it. Sorry. Option A is going to be the correct one, right? Yeah. Let's proceed. Yes, very good. Let's proceed. Which one of the following is a homoleptic complex? So, homoleptic complexes whenever in the coordination sphere itself, you will be having only same type of ligand. That is called homoleptic complex. And heteroleptic complexes, whenever in the coordination sphere, you will be having different type of ligand. Okay, so you can see option D is going to be the correct one, because in the coordination sphere itself, you are having only the same type of ligand. Repeat. Okay, which one repeat I have to? This one. Okay, this one. See the order, my dear. Cn minus after H2O, then F minus, then Cl minus. Mistakenly I did this one, because here you can see Cl is coming first, then F. Right? So that's not the correct order, right? So this is going to be the correct order. Cn, then H2O, then fluorine, then chlorine. So option A is the correct one. That's it. That's what I told, my dear. Okay. Let's proceed. Okay. The ligand which forms more stable coordination complexes, that is oxalate. Why oxalate? Because it is a bidentate ligand among them, right? It's a bidentate ligand. So as the denticity will increase, it will form a more stable complex. Okay. Yeah, Rafiullah, please tell me if you are having any doubt. Please tell me. Let me know. Distortion. Cn minus, no beta, Cn minus is ambidentate. It has two donor side, but it donates from a single end at a time. It has two donor side, I accept that, but it donates from one end at a time. So it behaves like a unidentate only. Okay, so that's not gonna be stable. But whenever it comes to the oxalate, from the two end, it's going to take the metal like that. Okay, so that's the reason the stability increases as the denticity increases. Like as you can see, I'm having, let's say, 5 finger. 5 finger means, let's say denticity is 5. So I'm holding a metal like this. It becomes very much stable. Okay, that's why any kind of chelating ligand becomes very much stable, my dear. Okay, and remember, Cn minus, it has two donating side, but it is an ambidentate ligand. It donates from a single end. Okay, Rocky Gamers, please tell me, why isn't it stable? No, beta, Cn minus is not stable because it is an at the end of the day, it is donating from a single end, right? Whenever denticity will increase, it will be, the metal will be attached with more site. Okay, it will be captured by more number of atoms, then it is more stable, right? Let's say any substance, let's say this phone, I'm holding this with single hand, and now I'm holding it with two hand. Which one is more stable? You tell me. This one, right, rather than this. Anyone can snatch it like that, but if I'm holding it with two hand, then it's difficult comparatively. It is also the same case. Okay, let's proceed. What are transition elements? Give an example. I guess you people already know it. I'm not writing the answer here. Transition element means D block element who are having incomplete d orbital in their ground state, right? Incomplete d orbital. D block element is also mercury, also zinc, but they are not transition elements. Why? That is also a question that comes out of it. Okay, so why zinc and mercury, they are not transition? Because they are having full-filled d orbital. If you are having full-filled d orbital, how the electrons will be like changing their position, right? So yeah, let's proceed. Using the valence bond theory, explain the geometry, hybridization and magnetic property of COF6 3 minus. Okay, so yeah, any doubt? Incompletely filled d orbital. Okay, very good. What is X iron, my dear? Okay, you are so cute. Thank you, my dear. You are even more cute. I know this. Can you please tell me what is X iron? I didn't get it. Okay, so valence bond theory, I will explain this COF6 and then NiCN. See, the compound that I have chosen, this is a strong field ligand, this is a weak field ligand. Okay, with respect to this, I can show you the inner orbital complex and outer orbital complex. Okay, oh my god, thank you so much. Thank you. I love you too, my dear. Okay, so let's proceed. Let's proceed. How you should show, it's a 3-marker question, step wise you have to go. Okay, let's proceed. So once you are having cobalt, this is cobalt 3 plus, right? So cobalt 3 plus is basically having 3d6 configuration. 3d6 configuration. So right, let me just write down 3d6. I am having 4s as well. I am having 4p as well, right? So 3d6 means 1, 2, 3, 4, 5, 6. This is your CO3 plus. It is in your ground state, right? Now CO3 plus in this dagger sign means it is in the activated state. Okay, so in the activated state, what will happen? As you can see, the ligand is fluorine here. It will not force pair this electron to get paired up against Hund's rule, right? So as a result of this, if hybridization needs to be done, then it will be done here outside. So by default, I am having 4s, 4p and 4d. 1, 2, 3, 4, 5. This is your 4d. So 1s, 3p and 2d is enough to accommodate 6 f orbital, 6 fluorine. 1s, 3p, 2d. So 3d is as it is. It will be as it is like that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and here I will be having one hybrid orbital. 1, 2, 3, 4, 5, 6. Okay, this is your sp3d2 orbital and 3d orbital will be left over. Okay, so here my fluorine will come and it will make the 1 fluorine, 2 fluorine, like that. The fluorine will make the bond. Okay, I guess it's clear to you. And as you can see, I am having 4 unpaired electron. So it is definitely, it's going to be paramagnetic in nature. And any case, if you are having 6 ligand attached to it, you can tell it octahedral. One more thing, please look into this thing. It is utilizing the nth d orbital, 4d orbital it is using while hybridization, right? Nth d orbital is used while hybridization. So you can call it outer orbital complex. Okay, I guess it is clear. And paramagnetic, sometimes they can ask you like you can find the magnetic moment out of it. So magnetic moment, I'm just writing mm, okay, equals to under root n into n plus 2. You can put the number of unpaired electron here. Okay, and please put the unit as Bohr magneton. Okay, I guess this concept is clear to you. Okay, let's proceed. Okay, I can see so many of you giving answer. Very good, my dear. Make sure it's a 3-marker question. You are doing all these things to show stepwise. Okay, let's proceed with this one. This one you tell me. Okay, so nickel 2 plus here. Nickel 2 plus, what is the electronic configuration? Who will tell me? So basically I am having 3D8 configuration, right? Okay, so 3D8, if I just draw, it will be something like this: 1 2 3 4 5, 1 2 3 4 5 6 7 8. It's like that. This is my 3D, this is my 4S, this is my 4P. Okay, so now here I am having cyanide, right? Here I am having cyanide. So cyanide will force pair the electron against the Hund's law. Cyanide will force pair the electron against the Hund's law. So here one electron will be paired up here. You can see whenever nickel will go to the activated state, when nickel 2+ will go to the activated state, then it will form something like this. Like this, okay? So 1D, 1S, how many ligand you have to accommodate? 4, right? So 1D, 1S and 2P, so DSP2, right? So this DSP2 will accommodate the cyanide, right? So now you can tell that here n-1th d orbital, n-1th d orbital means, you can see 4 is the outermost orbital, but here 3d orbital is used, so you can tell that it's an inner orbital complex. Okay, and what about the magnetism? Tell me. There is no unpaired electron at all, and hence you can say it is diamagnetic in nature. Okay, now tell me about the shape. Tell me about the shape, geometry. Whenever Cn is 4 here, right? Cyanide is 4 here. So whenever you will see that I am having 4 ligand out of it. I am having 4 ligand. Okay, there are 2 options. It can be tetrahedral or it can be square planar, right? But let me tell you, my dear, nickel usually form all the time, most of the time it forms square planar complex. Nickel, platinum, palladium, all of them. Okay, one more thing, that whenever you are having strong field ligand, they form square planar complex always. Whenever you are having weak field ligand, then they form the tetrahedral. Cyanide is a strong field, so it is a square planar. I guess it's clear to you. Let's proceed. Okay, now we are entering into the organic. Chalo, let's proceed. Okay, so here a little bit MCQ we will proceed with. Triiodomethane was used earlier as an antiseptic. The antiseptic properties are due to liberation of iodine. Sorry. Oh, blossoming flora is champion over here. Okay, let's see. Let's proceed. Here you can see when an alkene reacts with a component X in CCl4, reddish brown color of component X disappears to yield vicinal dihalide component X. Tell me, component X is Br2, bromine gas, Br2 in presence of CCl4. Let me just show you. If you are having any alkene unit like this, in case you are giving Br2 in presence of CCl4, then this brown color, this yellowish color or brown color, whatever they are giving, this brown color will be vanished when they will form this type of compound, vicinal dibromide. Vicinal dibromide type of compound. This is brown color and this is colorless. I guess it's clear. Let's proceed. Okay, this one, the major product formed in the reaction, in the following reaction. Tell me. Okay, so here you can see alcoholic KOH. There is a magic with the KOH, you know. Aqueous KOH will give you SN2. it will do SN reaction, substitution of nucleophilic. So SN1 or SN2, it depends upon the alkane that you are using, alkyl halide I mean to say. Okay, but if you are having alcoholic KOH, then it will undergo dehydrohalogenation. What it will undergo? Dehydrohalogenation. Yes. So देखो एक मैजिक होगा यहाँ पे. So I am having, let's say, CH3, CH2. Wait, let me just show you proper by breaking the bond. Okay, so now here you can see in the, I am having two beta position. This is also my beta position, this is also my beta position. So I have two different way to proceed with the thing. If this breaks down and this go, I will get something like this. CH3, CH, double bond, CH, single bond, CH2. Okay, now one more method. I can proceed with this and this can go, hence I can get the product something like CH3, CH2, CH, double bond, CH2. I am having two alkene. Now which one will be major? Which one will be major? Okay, pink DP is saying A, Gia is saying D. Okay, let me tell you, my dear. Okay, bun, coffee, something. D. Okay. So the correct answer is going to be option D. Why? Because it is following the Sedzev rule. What is Sedzev rule? More substituted alkene will be more stable. This particular alkene, if you just see, C double bond C, I am having one CH3 hydrogen, CH3 hydrogen. See, this particular alkene unit is having, this is my alpha hydrogen, right? How many alpha hydrogen? I am having total 3 plus 3 alpha, total 6 alpha hydrogen, right? Total 6 alpha hydrogen. 6 alpha hydrogen will stabilize the alkene unit with hyperconjugation, Sedzev rule. But here, if you just break it down, C double bond C, here hydrogen, no alpha hydrogen with this carbon. Here I am having CH2, CH3, and here I am having hydrogen, normal hydrogen. So I am having only 2 alpha hydrogen here. So which one is more stable? This one. This is my major product. Okay, so correct answer is going to be option D. Please let me know if it is clear to you or not. Pink DP, please tell me. I guess it's clear to you. Okay, you will get two product. This will be major one, this will be minor one. Okay, I guess you understood Sedzev rule. This is Sedzev alkene, more substituted alkene. Okay, then what is the reason? Okay, I wrote here a CH2. Then someone of you will tell me, ma'am doesn't know what is the valency of carbon. Okay, I know. Okay, pink DP lol. Okay, don't make fun of him, it's fine. Let's proceed. Chalo. Okay, what is this reaction? Tell me first. Tell me this thing. This is your Finkelstein reaction, right? Okay, let's proceed. The reagent used in the Sandmeyer's reaction. Tell me the answer first. Okay, very good. CuCl2 HCl. CuCl2 and HCl. Very good. Next, write the SN2 mechanism for conversion of chloromethane. Very important, my dear. SN1 and SN2. Okay, the mechanism is very important here. Okay, let me show you. Let's say I'm having chloromethane, right? CH3Cl, right? So for definitely to proceed with the SN2 reaction, definitely your backside should not be hindered, right? SN2 reaction is a single step concerted mechanism. It follows a single step concerted mechanism, right? So now if you give some OH minus out of it, OH minus will attack on this carbon, chlorine will leave. Okay, but it proceed through a transition state. Intermediate, not intermediate, better to say transition state. So here what happens, the leaving group not yet left and the nucleophile not yet attached. So carbon is delta positive here, this is delta negative, this is delta negative. So this is basically hydrogen, hydrogen, hydrogen. So here you can see penta-coordinated. Just look at the pathetic situation of carbon. Penta-coordinated transition state, let me write. Okay, it proceeds through a penta-coordinated transition state where carbon has two partial bond, one with the leaving group, one with the upcoming nucleophile. Okay, so now what happens, it has to leave any one of it, then you will get carbon, hydrogen, 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 and here you will have the OH. Okay, so one more thing that I can tell here, that is, if you are starting with a asymmetric carbon, chiral carbon. Okay, chiral carbon. If you are starting with a chiral carbon, then you will get inversion in configuration. You will expect inversion in configuration. Okay, if you are starting with R, then you will end up with S. This is not chiral. But if you take a chiral carbon, it will happen, inversion will take place, right? It is something like tilted umbrella, right? So I guess it's clear to you. Let's proceed. I guess this is clear. Definitely it's proceed. It is having a second order kinetics because both the concentration of this, let me show you, R equals to K into concentration of CH3Cl as well and OH minus as well. Both of them are involved because only single step, no. So both of them will be involved, power 1. So overall order is 2. Like this. Okay, let's proceed. Write the SN1 mechanism. Okay, SN1 is a two-step mechanism, right? So yes, let's proceed. Let me take this type of thing. Tertiary butyl, let's say chloride. Okay. So what will happen here at first, tell me? The first step is the slowest step, right? Mention every detail. Hence RDS, rate determining step. We will determine the rate in the first step itself. For the SN2 there is no other option, right? So here what happens, the leaving group leaves the system. Okay, leaving group leaves the system and the carbocation intermediate is generated. So I will end up with a tertiary carbocation. So 3 degree carbocation. Okay, that is an intermediate. Okay, it proceeds through the carbocation intermediate. Okay, so this particular step is RDS. So as it is RDS, if I just write the R, I mean rate, so K into here, did you see any nucleophile? It's not yet come. So K into only this, right? Power 1. So that's the reason it's a first order reaction, because nucleophile has not involved in the first order, I mean in the first step. Now you are having, let's say, OH minus will attack over here and you will end up with CH3 tertiary butyl alcohol, right? CH3 here, OH. This is the first step. Okay. I guess it is clear. This is how you should proceed. And here what you will get? Tell me. If you are starting, let's say if I am starting with a chiral compound, if I am starting with a chiral compound, then let me just write it. For SN, first one we did SN2. For SN2 we will see inversion, right? Inversion. But if I am doing SN1, then I will get racemic mixture. I will get racemic mixture of both R and S. Okay, very important thing. Okay, so exact if I go even further depth, actually if you proceed for the JEE Mains or NEET, then it's very important to understand the concept. In the racemic mixture, definitely proper 50-50 you will not get. One a little more, another one is little less. Okay, just because after leaving Cl, it stays few minutes here. Okay, just after the Cl leaves, it can't just run from the system, right? It will stay here for some minute. That's why OH minus attack a little bit back. Okay, so that's the reason you will get some inversion product as well, more, right? So that is the reason. Okay, just a secret I'm sharing with you. Racemic mixture, okay, as of now you remember for the board purpose racemic mixture, but in case you are proceeding with the JEE Mains, advanced, whatever, then please remember this small concept. Okay, just if you are interested, just go through it once. Okay, Netflix shorts. Ma'am, are these PYQs? Yes, sort of PYQs you can tell. Yes, some questions are taken from the JVIT, some questions are taken from the, what it calls, model papers. Okay, these are the most important questions that you can expect, the top 50 you can call. Okay. Dhanush, my dear, SN1 will give you racemic mixture, my dear. Okay, SN1 will give you racemic mixture, my dear. Okay, and SN2 will give you the inversion because the structure get tilted. Okay, Dhanush. Let's proceed. Okay, this is alcohol, phenols and ethers. So yes, the first question, tell me, it is taken from the model paper. The benzylic alcohol, how it looks like? Dhanush, please reply. This is your benzylic alcohol. Okay, I know what Dhanush is doing. Dhanush is actually, once the ma'am is against me, okay, what I used to do, I will just go to the Chrome and I will tuck, I will just search if ma'am is true or not. Okay, that's what Dhanush did. And then he answered. Okay, so this is your benzylic alcohol. And another one is vinylic alcohol. Vinylic alcohol means C double bond C, that is directly connected to the OH. Okay, so as you can see, this, okay, I'm coming to the solvent. If you just look at this carbon is basically definitely sp3. Okay, and this carbon is definitely, it's going to be sp2. Okay, so what they are asking, in vinylic alcohol OH group is bonded to a carbon-carbon double bond. Yes, that is true. So both of them are correct. Okay, so D-Tech, amazing name. Okay, he is asking what is polar protic solvent. Let me just tell you the role of a solvent over here. Sometimes you can get the MCQ out of it. Okay, in the previous year the question came. Listen properly. Okay, so polar protic, polar means what? Polar means the solution that is having the dipole moment. Let me just give you the example of water. Okay, so here hydrogen is bounded with electronegative oxygen. So here I am having the electron density. So dipole moment direction is this. Dipole moment direction is this. So resultant will come something like this. Okay. So definitely water is a polar molecule, right? So polar term is like you understood. Now what is protic? Protic means proton donor. Proton donor. Okay, water molecule can donate H plus, right? So polar means this type of molecule, whenever it will be dipole moment positive, dipole moment greater than 0, okay, and protic means proton donor, means it will give one H plus in the medium, H plus in the solvent, okay. So for SN1 reaction, if you ask me what type of solvent you need, definitely polar protic solvent will be more helpful for you, because the intermediate that is formed over here, it is positively charged, right? It is charged. Anything, any case, if you see the intermediate that is formed is charged, positive or negative, then please give polar solvent. Polar solvent will help to stabilize the intermediate. So more intermediate, faster the reaction. Okay, I guess you understood this. D Tech. Pritham, ma'am, you are doing a great job. Thank you so much. You people are also doing a great job by listening this lecture. Okay, so thank you too. Yeah, please tell me. Okay, very good. Can we go back to alcohol phenol? This is done. Okay, next question. Acetylation of salicylic acid produces a compound which has anti-inflammatory and antipyretic property. So that's going to be aspirin, my dear. Aspirin, okay, the first analgesic medicine in the world. Beautiful story is there behind the discovery of the aspirin. If you are interested, please once you check that. Okay, let's proceed. Salicylaldehyde can be prepared from which of the following reactant? Okay, definitely phenol, chloroform and aqueous NaOH. You know this, but I want you people to tell me the name of this reaction. Tell me the name of this reaction. Fast, tell me the name. TR reaction. Another one is saying Kolb's reaction. Which one is the correct? Reimer-Tiemann or Kolb's? Who will tell me? Okay. Reimer-Tiemann reaction. Okay, very good. Let's proceed. It's not Kolb's reaction, my dear. In Kolb's reaction, salicylic acid is produced. Okay. Proceed. Okay, very important question, very important zone. Okay, cumin hydroperoxide on hydrolysis of dilute acid. What it gives? Cumin to phenol synthesis, right? You will end up with phenol along with acetone. Sometimes they tell that, yes, phenol you will get, fine. Along with that, what you will get? Acetone. Important, huh? Let's proceed. The method used to separation of isomeric products obtained when phenol reacts with dilute HNO3 at low temperatures. So if you treat phenol with dilute HNO3, what you will get? Orthonitrophenol and paranitrophenol. The magic in this is orthonitrophenol. It will undergo intermolecular hydrogen bonding, and what I'm saying, orthonitrophenol, if you see, let me just do it for you, it will undergo intramolecular hydrogen bonding. Okay, intramolecular hydrogen bonding. And if you just look for the para, it will undergo intermolecular hydrogen bonding, right? For the inter, you need more temperatures. Just temperature is high for inter, and for this temperature is low. So steam distillation will work for it. Okay. Who said solidification? D. Dhanush. Why? Solidification will not work, my dear. This is steam volatile, my dear. Okay, so it will be volatile. It will come fast after that paranitrophenol, because it is intermolecular hydrogen bonding. Why don't you use DMSO in SN2 molecule? At first you tell me if DMSO is polar protic or polar aprotic, or it is polar solvent or non-polar solvent. That you tell me at first, then I will answer you. Let's proceed. What is Lucas reagent? It's a direct question. Okay. Yeah, aprotic though I understand. Aprotic you don't need it to be, like proton you don't need in the SN2 reaction. By looking at the mechanism you understood that, because there is nothing that in which step you need H plus. And if you just look towards the molecule itself, overall molecule, to stabilize the nucleophile itself, to stabilize the product, to stabilize the reactant, everything, it is polar only, right? If I just go back to SN2 thing, look at the product, my dear, isn't it polar? So definitely you need polar solvent. If you use one non-polar solvent, then neither this thing will be soluble, right? It will not be soluble over there, right? If the things are not miscible, then how the reaction will take place, you tell me? Why you are using a solvent? So that to mix this, right? If they are not miscible, then how will you continue with the reaction? That's why polar solvent, because you are using polar molecule here. Your product is polar molecule here. So polar aprotic solvent, because hydrogen I don't need. I guess it's clear? I guess it's clear. Please tell me. Ban kafi. Okay, please tell me, my dear. Yeah, I'm going back there. It was a good question, by the way. Okay, let's proceed. Okay, phenol and acetone, this thing we did. Okay, Lucas reagent, very good. ZnCl2 and HCl. Okay, now which class of the alcohol produces turbidity immediately? Tell me, fast. 3RE, okay, distortion, tertiary, okay, tertiary will produce the turbidity first, right? I guess there is no doubt. Next, Cole's reaction with equation. Here comes the Cole's reaction. So this is your Cole's reaction. You can see who was doing the mistake. Salicylic acid is prepared. I'm not doing it, just it's done already in the answer part. You can see NaOH, if you give sodium phenoxide, further you give CO2, it will end up with the salicylic acid. Very important reaction. Next, write the 3 steps involved in the acid catalyzed dehydration of ethanol. Okay, let's do it. Very important question, that's why I felt like I should show this to you. First step is always, you remember, it's protonation. Whatever the step it's needed, you will see whatever the mechanism you will do in this level, I mean PU2 level, everywhere protonation, carbocation generation, deprotonation, it will follow like that. Okay, so protonation. Okay, so if you do protonation, let's say I'm having alcohol, CH3, CH2, OH, okay? Please add H plus, catalytic amount of H plus. Why? Because this H plus will come back. You will end up with the protonated alcohol, CH2, OH, 2 plus, right? Sorry. Next step is, what is the next step? That is nucleophilic attack. What is the spelling? Okay, nucleophilic attack. Here only the carbocation is generated, okay? For this thing, carbocation will not be formed because we are forming the ether group, right? So here I will take another one alcohol. Okay, I will take one more alcohol, let's say CH3, CH2, OH, and I am having, let's say, CH3, CH2, OH2 plus, right? Okay, so what happens, this oxygen, it attacks here and this OH2 plus is thrown out. Okay, actually protonation, what is the purpose of protonation, you know? To make OH a better living group. Okay, as a result of this, you will end up forming this thing, right? CH3, CH2, here OH plus CH3, CH2 plus from here water. Okay, next, okay, let me just tell you this particular step is low. Okay, means RDS. Last step, if I proceed, this is basically deprotonation. This is also first one. Okay, so if I proceed with the deprotonation, what will be that? I am having that one, right? CH3 CH2 O, here H, here plus, here CH2, here CH3, right? So what will happen basically, this bond will jump here and one H plus is released. Look at that, my dear. The H plus, it was used, just a catalytic, a very small amount of H plus is used here. That is coming back again in the last step. So you are ending up with the ethoxyethane, CH3 CH2 oxygen CH2 CH3, along with that H plus. This H plus will be used again. Okay, just let me know if you understood this thing or not. Yes, second step is SN2 attack. I guess it is clear to you. Let's proceed further. Let me know if it is clear. Yeah, you can just mention about the RDS and which step is fast, which step is slow. That's it. It's more than enough. If you proceed with the mechanism, it's more than enough always. Okay, let's proceed. Okay, it's a very important question actually. It's taken from the model question paper. First one, oxidation of phenol. It will give you what? Benzoquinone. It will give you benzoquinone. Okay, now for this case, bromine water if you treat, you will get all the thing will be substituted with bromine. Beer, here also beer. Okay, I guess it's clear. Very good, very good. Dhanush, blossoming flora, very good. Let's proceed. Okay, so this is the next step. You can see, write the steps involved in the mechanism of dehydration of ethanol to ethene. Same steps are involved, that's why I'm not showing. Okay, so here you can see protonation takes place, oxonium ion, the last step also it was formed. Okay, formation of carbocation. I told you it makes the alcohol a very good leaving group, hence CH3CH2 plus carbocation is generated. Then what is happening here? Like elimination of hydrogen, the last step as well we did. Okay, and you will end up with ethene. I guess it's clear. Proceed further. Okay, how the salicylic acid is prepared from phenol. I don't think that I have to tell this. Just in order to mention the most important question, I kept it. Alcohols are comparatively more soluble in water than that of hydrocarbons. Why? Because of the hydrogen bonding, right? Hydrogen bonding, alcohol can form hydrogen bonding, that's why it is more soluble in water. Okay, let's proceed. Okay, chalo MCQ karte. Okay, the common name of ethane dioic acid, what is this? Oxalic acid, right? This is oxalic acid. What is this? COOH, they are connected, ethane dioic acid. Proceed. Okay, the main natural source of acetic acid. 9th, 10th grade question. I won't tell this. Tell me, fast. This is vinegar, right? Okay, Covida, acid catalyzed dehydration of ethanol. Okay, definitely I can go back. So what is basically happening? I'm showing it here itself. Okay, let's say I am having CH3, CH2, OH. Okay, at first I will treat it with H plus, so I will end up with CH3, CH2, OH2 plus, like that. Okay, this is protonated alcohol. Now in the next step what happens? CH3, CH2, OH2 plus, it has become a very good leaving group. It will leave the system now and I will end up with a carbocation, CH3, CH2, carbocation. Got it? Next step, I'm writing here. Okay, next step, let's say I'm having this thing CH2, just breaking one hydrogen like that, and here I'm having CH2 plus. So this bond jumps here and one H plus is released. Okay, hence CH2 double bond CH2 plus one hydrogen I'm getting. Okay, this hydrogen again will be utilized in the first step. Okay, I guess it's clear, my dear. Yes, tell me. Okay, hydroboration oxidation. See, beta, you don't need the, what it calls. Okay, very good. You don't need the mechanism, okay? Hydroboration oxidation mechanism you don't need, but just remember one thing, just let me tell you. Let's say I am having this thing. This thing, okay? In case you are having B2H6 and in the same case I am having OMDM. OMDM means oxymercuration, demercuration. Okay, in case you are doing B2H6, the alcohol will be added in the terminal carbon always. Okay, alcohol will be OH will be added in the terminal carbon, and if you are doing OMDM, then the alcohol will be added in the intermediate carbon. This is the main difference that you need to remember. Okay, so one, it will follow, did I do it properly? CH, it should be CH. Okay, yes, anti-Markovnikov rule, very good. Anti-Markovnikov rule in B2H6, Markovnikov rule in OMDM. Okay, so there are different mechanism actually. If you see the mechanism, no, the anti-Markovnikov will not come. There is a different mechanism that actually end up with the method. Okay, here in the B2H6 we use peroxide. Okay, that's the effect. Here anti-Markovnikov takes place. Always remember, alcohol here will be added in the terminal carbon, here it is in the intermediate. That is the difference in between these two steps. Okay, I guess it's clear. Let's proceed. Aldehyde ketone. Okay, this question, tell me from your this thing, what it calls, model paper. Acetone and benzaldehyde. Acetone, you can see the carbonyl carbon. If you just look at that, it is a in between two thing, right? C double bond O CH3, and this is your benzaldehyde. Not benzaldehyde, benzaldehyde only. This thing. Okay, which does not react with both. Sodium hydrogen sulfide, yes, it will do, it will react. Phenyl hydrazine, it will also react. But if you just look at the failing solution will not be able to react with this thing. Okay, it can react with the aldehyde only, it can't react with the ketone. Okay, proceed. Okay, the base reagent useful for the separation or purification of aldehyde from ketone. Please, very important thing, my dear. Nucleophilic addition in carbonyl carbon. Okay, so that's going to be sodium hydrogen sulfide, NaHSO3. Okay, aldehyde is more reactive towards it. Aldehyde is more reactive towards sodium hydrogen sulfide, and it will make the bond with the aldehyde. It will do the nucleophilic attack if you are having aldehyde and ketone mixture. Okay, so aldehyde mixture will form the compound, and it is water soluble, it will form crystal. Further, if you just add dilute NaOH, further if you just add dilute HCl or alkali, you will get back your aldehyde and your ketone will be there in the solution itself. Okay, proceed. Not tolerance reagent, my dear, it's sodium hydrogen sulfide. It's a very important zone, it's there in the NCERT. Please focus on this. Definitely once organic chemistry will come, I will discuss this in detail. Okay, next, among the methanol and ethanol, which one will undergo Cannizzaro reaction? Tell me. This is your methanol. This is your methanol and this is your ethanol. Which one will undergo Cannizzaro reaction and why? So definitely this will undergo Cannizzaro reaction, right? This will not undergo Cannizzaro reaction. For Cannizzaro reaction, the most important condition is not to have the alpha hydrogen. So here I am having no alpha hydrogen. So this will not, this will undergo Cannizzaro reaction. I guess it's clear. Okay, let's proceed. Okay, explain HBZ reaction, the chemical equation, write the reaction conversion. Okay, I will show it. Okay, this is your HBZ reaction. This is basically in the alpha position you will get the halogen substitution. Okay, alpha halo substituted carboxylic acid if you want to get, you have to proceed with the HBZ reaction. What is the reagent? What was the reagent? red phosphorus and bromine, right, or Cl2, whatever you want, and water you have to give. Okay, so that is the reaction. Next, write the reaction for the conversion of toluene to benzaldehyde using chromyl chloride. What is the reaction? ATAD reaction, my dear. Okay, so this is your ATAD reaction, toluene, chromyl chloride if you give, chromium complex, from there benzaldehyde. Very important. Name the gas used to facilitate the nucleophilic addition of ethylene glycol to aldehyde and ketone. That is HCl gas, dry HCl gas. Okay. Okay, PU1 candidate come. Okay, my dear, 2 to 3 marker question, you go and watch. Okay, more or less everything I covered over there. Okay, please revise the entire thing. That will help you. Okay, let's proceed. Amines. Okay, let's proceed. The chemical formula of Hindenburg reagent. What is that? Benzene sulfonyl chloride, this option C, right? And please Hindenburg reagent related question, that how you should use Hindenburg reagent to separate primary, secondary and tertiary amines. Okay, proceed. Which of the following groups when present at para position increases the basic strength of aniline? So I have to use a group that is electron donating, right? So you can see I can use NH2 group that will donate the electron further, so that the lone pair on the nitrogen of aniline group, it gives it can donate the electron further. Okay, electron donating group needs to be added. Proceed. Distortion. Okay, very good. Okay, which type of amines answers carbylamine reaction? Yes, tell me. Give the answer, then I will proceed. Primary amine. Very good, Dhanush. Very good. Primary amine. Explain the reaction with an example. I'm just directly showing you this. Okay, so basically this is the primary amine. Here in the next question again the carbylamine reaction explanation is there, so that's what I put here. You can see a primary amine in presence of chloroform and KOH, it will give you the isocyanide that is of foul smell. If foul smell is coming, you can tell that yes, my compound is containing primary amine. Okay, this one you tell me. For this case definitely this N2Cl will be gone. I'm writing here. Okay, you will end up with a fluorine here, along with that you will get BF3, right? I guess it's clear. Okay, let's proceed. IUPAC name of this, it's also given propan 1 amine. Okay, biomolecules, the last chapter finally. Okay, let's proceed. How many of you present over here are scared of this particular chapter? Anyone present over here scared of biomolecules? Tell me. Option A. Okay, option A means you are not scared. Vitamin C. Which of the following acid, in the following acid vitamin is ascorbic acid, vitamin C. Okay, me, Gia. Okay, Gia, biomolecules chapter is a very easy chapter, you know. D-Tech. Okay, you are also scared of this chapter. Okay. So I have to come up with some trick. Okay, so in the organic I will add some trick for the biomolecule chapter. Okay, don't forget to watch that. Okay, tell me this thing. This is taken from the model paper question. I am a CA student. It's a very, you know, so you are a CA student, it's okay, but biomolecule is a part of chemistry. Okay, so you have to go along with it. So yes, you know, you people can choose PCMC or PCMB, okay, because you are either from the for the JE background or for the NEET background. Okay, I am from Bengal. There is a concept of pure science. Okay, pure science you have to proceed with PCMBC. Okay, so that's very interesting. Okay, so if you wish you can try this once. Okay, PCMBC, it's a very nice combination. Okay, so you can proceed with both medical, both JE. Okay, so yes, please go ahead with it. I always insist my student. Okay, doctor advised a 50-year-old woman enough exposure to sunlight and addition of fish and egg yolk to her diet. Name the vitamin deficiency for the possible disease diagnosed by the doctor. Okay, so basically this is vitamin D. Okay, Whenever it comes to the matter of exposure of sunlight, you understood that. Okay, this is a very important question. Okay, what type of linkage? Peptide linkage. Yes, please tell me. This is A, right? Amino acid. Glycosidic linkage, monosaccharide, that is going to be C. Phosphodiester linkage, nucleotide, D. What is the correct option? Option D, right? Hey guys, please answer. From the morning itself, without having breakfast, I am taking your class and you people are not answering. Answer first. Okay, very good, very good, very good. Distortion. Okay, let's proceed. Okay, next question you can see, water reducing sugar, right? The Hawa structure of lactose, so lactose, maltose, any one of the structure will come. Okay, please make sure that you are practicing these structures. Okay, and the hormones are needed for adequate quantities in our body. Give the reason. What is the backbone of DNA? Okay, first thing is reducing sugar. Reducing sugar means that can reduce the phalanx, tollens or Benedict reagent, right? Because it is having one open aldehydic unit that can reduce the groups, phalanx and tollens. So that is basically reducing sugar. This is the lactose Haworth projection, okay? And another thing is hormones, it's needed in the adequate amount. Why? Because hormone regulates everything in your body, like your growth, your mood, your sleeping pattern, everything, reproduction, your characters, everything. So in case they are not in a proper or in an adequate quantity, definitely you will proceed with some, you can face some disorders related to the deficiencies, right? That's not expected, right? Next, what is the backbone of DNA? Definitely it's nucleotide connected by phosphodiester bonds. Okay, I guess it's clear. Okay, let's proceed. Okay, so finally we are done. Okay, Sridhar, Sri, hi, you are too fast, my dear. We are just at the end of the session. So my dear, I guess I could cover the entire syllabus, the numerical zone mainly and the MCQ part, and please, for the theoretical part in the physical chemistry, please make sure you are watching the physical chemistry, that particular video. It will come very soon. And yes, the trick I will tell in the organic chemistry class. There will be trick, don't worry. For Gia especially, I will mention your name there. Okay, so yes, keep practicing, keep boosting up your knowledge. And yes, don't forget to just a single thumbs up, give a single thumbs up. It will not take that much effort. Share the session, and if you have not subscribed, then please do subscribe. Thank you so much. Bye-bye to all the students. Thank you for interacting so much. Have your breakfast and don't forget to Okay. Pink DP is saying go and have breakfast. Okay. So you also have your breakfast, and yes, don't forget to what? Practice. Don't forget to study. That is the only strategy you should follow. Bye-bye. Yes.